Students, we will learn today how to solve integral 0 to 1 tan inverse of x positive tan inverse of 1 negative x times dx. And we have to show that it is equal to pi over 2 negative log of 2. Now, foremost, write down the step. Consider integral 0 to 1 tan inverse of x positive tan inverse of 1 negative x times dx. After this can be rewritten as integral 0 to 1 tan inverse of x times dx positive integral 0 to 1 tan inverse of 1 negative x times dx. Now just rewrite this 0 to 1 tan inverse of x times dx positive. Now when it comes to this, what we are going to do, we would be using this formula. We know that integral 0 to a f of x times dx is equal to integral 0 to a f of a negative x times dx. Now since we know this formula, tan inverse of 1 negative x, this can be rewritten as integral 0 to 1 tan inverse of 1 of, in the place of x, we would have to substitute 1 negative x times dx. Okay. Rewriting this, we get 0 to 1 tan inverse of x times dx positive integral 0 to 1. Now, this is nothing but 1 negative 1 positive x. If you were to expand this and remove the parenthesis for the second term. And this has to be product multiplied with dx. Now clearly the positive 1 and negative 1 can be cancelled, so you would now have integral 0 to 1 tan inverse of x times dx positive integral 0 to 1 tan inverse of x times dx. Now we would add these two terms together, and that would give us 2 times integral 0 to 1 tan inverse of x times dx. Now this is inverse trigonometric function, right? Now to integrate this, we will have to use integration by parts. So what is that? We know that u times dv is equal to uv negative integral v du. So this is the formula we know. And we also know the important law, Liate, L-I-A-T-E. Now I is an inverse function, so the order is 2. So u should be taken as tan inverse of x, and dv should be taken as dx. Now if you were to differentiate u, differential of tan inverse of x would be 1 over 1 positive x squared times dx, and to get dv you will have to integrate. So if you have to integrate dv, you get v. Integral of x would give us, integral of dx would give us x. Now substituting it in this formula, we now have integral 0 to 1 tan inverse of x times dx, of course there's a constant 2 there, is now equal to 2 times uv. My u is tan inverse of x, that has to be multiplied with v, which is x. The limits are 0 to 1 and followed by a negative sign, integral 0 to 1. My v is x, my du is dx divided by 1 positive x squared. So place it in the parenthesis. Now this is equal to 2 times, substitute the upper limit, so you get 1 multiplied with tan inverse of 1 negative 0 times tan inverse of 0. This is for the first component. Okay, let me place it in square parenthesis. Now for the second component, we got integral 0 to 1 x dx divided by 1 positive x squared. So what I'm going to do, I'm going to show you how to integrate this component. So let me take it down here. Consider integral 0 to 1 x dx divided by 1 positive x squared. So what I would do, I would let 1 positive x squared be equal to some t. When you differentiate, you get 2 times x dx is equal to dt. We only have x dx, so x dx is going to be dt divided by 2. Now if you substitute it here, this is going to be integral. In place of x dx, substitute dt divided by 2. In the place of 1 positive x squared, substitute t. Now we know integral dt over t is going to be log t. So this is equal to 1 over 2 times log of t is 1 positive x squared. I have not touched the limits at all, so the limits retained for the variable x. Now if you were to substitute the limits, you would get 1 over 2 times log of 1 positive 1 squared negative log of 1 positive 0 squared. Now this is going to be cancelled because you will get log 1. So this is equal to 1 over 2 times log of 1 positive 1 squared will give you 2. So you have something like 1 over 2 log 2. So what you got to do, this is just to show you how the integral of x divided by 1 positive x squared is solved. So now what I'm going to do, I'm going to substitute the finding. So this is equal to 2 times 1 times tan inverse of 1, we know pi over 4. So it's going to be 1 time pi over 4 negative the value of integral 0 to 1 x dx divided by 1 positive x squared is 1 over 2 log 2. Okay, so this is equal to 2 times pi over 4 negative 2 times 1 over 2 times log 2. Now 2 divides 4 2 times and the 2's here can be cancelled, giving us pi over 2 negative log 2, which is equal to the right hand side. Hence the result is obtained.